All right, so here we are. We're going to review the first test, okay? And our short answer questions are not supposed to be high computation. A lot of people did unnecessary work, okay? I got a lot of questions during the test. What is an interval? You didn't know it, you couldn't answer the question, okay? Here's the interval. This is a set of numbers which is expressed here in inequality form, and then here in interval form. Number two, if we have the graph, the thing was to make the connection here, okay, between the graph of an equation and the graph of a function, I should say, and the solution to the equation. I had suggested to you and that you can find the solutions to your equations as the x-intercepts of your graph. So here we are. The x-intercepts are 2, -1, and 3. Okay. Next, you have to express this set of numbers. X absolute value is greater than 3. That means 3 is inclusive and everything to the right. Okay, and -3 is inclusive and everything to the left. The set of all, or the 2 points other than these, the points that are 10 units away from the origin. Okay, what I was hoping was you were thinking the Pythagorean triplets, the 6, 8, 10s. Okay, so any combination of 6, 8, 8, 6, okay, along with variations on the sign. Some of you gave me some ones over here. Some gave the 45, 45, 90 combinations, or the 36, 90, 30, 60, 90. They were valid as well. Okay. Number 5. This was a winner. Here, for what values is this statement true? Now, basically, if you understood what it says, then you had no problems, because this says, if you recognize that 2 minus x is the opposite of x minus 2, it's saying, when does the absolute value of something turn that something into its opposite? Well, it turns it into its opposite when the value inside the absolute value is less than 0. So basically, when the value inside here, x minus 2, is less than 0, I guess we should actually say less than or equal to, or when x is less than 2. Sample any value. Some give 1 value. There's no 1 value. Okay. Some gave 2 values. There are all these values. All the values less than or equal to 2. Okay. Our equations. Here. This equation set is the tone set for that is U substitution. Of course, it is also a fractional expression, so you got to identify what you cannot let the variable be, mainly 1. By letting this parenthesis expression, this t over t minus 1 be U, it then is quadratic, and it's easily factorable. U is equal to 1/5. U is equal to -3. It's not. Our interest is not what is U. So we return the t over t minus 1, cross multiply and solve for 2 solutions to this. Neither one of which is 1. People are making a lot of work for themselves here, and unnecessarily so. Okay. Some people made this into a fraction, multiplied by a common denominator. It's valid, but a lot of you run into problems with that. Okay. Equation 2. Swing everything to the one side, setting the right side equal to 0. Then it's a factor by grouping. Split it down the middle. From the first 2, common factor 4x squared. From the second 2, we got to pull out a -1 to have these binomials match. Okay, and then we factor by the common binomial factor, mainly the x minus 3. This subsequently factors, offering us 3 solutions, plus or minus a half, as well as 3. Okay. Some people got an AA here. AA, algebraic atrocity. You factored it on both sides and you divided through by x minus 3 and lost the solution in doing that. That was a biggie, a big offense. I think it was 5 or 6 points off. Okay. Here, this number 3, fractional equation. The idea of fractional equations is get rid of the fraction, and the cleanest way of getting rid of the fraction is to multiply by the least common denominator, which between 4, 6, 2, and 3 is 12. So everybody multiplies by 12, which has a clearing effect in the denominator. 4 goes into 12, leaving 3 to distribute. 6 goes into 12 2 times. Here's a big mistake. The minus sign. Didn't carry it down, didn't distribute it. You got it circled right here because your sign was wrong, resulting in the wrong final answer. It resolves itself to a simple equation. However, some of you just made it more difficult for yourselves, unfortunately. Okay. Over here, fractional equation with algebraic denominators, x can't equal 0 or -1. This one factor contains both x and x plus 1, which is in fact a common denominator. We multiply through by the common denominator of both x and x plus 1. The x's cancel out with this first term. This is a binomial squared that's factored down here. X squared minus 1x minus 12. This is a difference of squares, right? X squared minus 1. Comes down. Interestingly enough, this problem was quite interesting because when this factors, it offers you a solution of -1, but the red flag should have gone up to tell you, hey, it can't be -1 because you said so up here. Now, those of you who didn't say it up here didn't realize it when you came down here to the bottom and then and gave me a valid solution here, okay, when it really wasn't, okay? Some put this strike up here. This, of course, is x cannot equal. It should be slashed through those, okay? And then didn't realize it when you got down here. So, you know, you didn't tell me what it couldn't be. You lost a point. That one or number 1, okay? And then if you come down here and told me it could be when it really can't, that's canceled out. There should be an x through this. You lost another point, okay? All right. Absolute value inequalities. Isolate the absolute value. Isolate the absolute value. Subtract 2. That gives you -15. Divide by -3. There you go. There's a red flag. Dividing an inequality, of course, with the less than or greater than sign. Dividing the inequality by negative switches the sign. Okay, so it goes from less than or equal to greater than or equal to. The format says a term greater than an absolute value term greater than a number is the cost of removing the absolute value bars is to write 2 expressions, one comparing it to the number with the same comparison, the other comparing it to the opposite of the number with the opposite comparison. You come down, you solve, it asks you in the directions, write as interval form. There again, we got people who don't understand what that's asking for, therefore you couldn't answer it, okay? Interval forms are going to be pivotal with most everything we do here, okay? Here, number 2, okay, 5 points each, okay. For values of x between 2 and 5, sample value 3. 3 minus 2 is positive, no change. Therefore, it comes down, no change. The absolute value bar is removed with no change, okay. Another value or the same value 3 placed in here, 3 minus 5, negative, okay. So this will result, this inside x minus 5 will always be negative for this collection of values. Therefore, the cost of moving the absolute value bars is to take the opposite. So I take the opposite. Now, some people left it hanging here. It's not simplified. If it's not simplified, you're either hung up on you don't know what to do, or you're not sure. And then some people, again, the minus sign is going to impact both of these members after it. This comes down to 3. Okay. Similar approach in this, the same expression, but for a different set of values. X less than 2. X less than 2 here, it goes negative. So therefore, okay, the cost of removing the absolute values is a negative, the opposite, I should say. Likewise, it goes to a negative expression. The x minus 5 will be negative for all x is less than 2. Okay, therefore, this has got to be compensated for with a minus sign out in front. Again, distribute the minus sign. I don't know how many times I circled that on people in not only this problem, but other problems where you have the same impact. Comes down to negative 2x plus 7. Okay? Show that the triangle is a right triangle. This is easiest just by, I did a simple sketch just to get a notion of, well, what sides look to be perpendicular. So it's looking as if the AB and AC sides are perpendicular. So I check their slopes. One is 3/4, the other is negative 4/3. You have to make some kind of claim. I told you one way of stating perpendicularity is to show that the product of the two slopes is -1. People say they're perpendicular because they're negative reciprocals, but this is stated a little bit more, a little bit more algebraically kosher here, if you will. Okay. Here, again, a sketch can always prove helpful. Okay. So with the sketch, it says that C is the midpoint. C is not an endpoint. So one of the endpoints is at 6,4. The other, B, is unknown. So we tag that as XY. We use the midpoint formula. Okay, X plus 6 divided by 2 is equal to -3. Simply solve. -2, or -12 rather. And then likewise for the Y coordinates, Y plus 4 over 2 is supposed to equal 6, so Y is equal 8. Midpoint is -12.8. And lastly, the distance formula. Okay, so applied to this problem up here, what is the length of the circumference of the circle? Geometrically, circumference is 2 pi r. So r is, of course, the distance between the center of the circle here at -3,6 and either the 12.8, -12.8, which we recently acquired, or the 6,4. So anyway you look at it, this comes down to radical 85. That's the radius. Okay, so 2 radical 85 times pi is the circumference. I mean, the area could have been found just as easily. All right. So the point tally for on each page is in the lower right-hand corner, and that's our recap of that first test. Hope you did well.